Imagine stepping into a world where the average winter temperature is, around -25 Celsius.
And that's the average. It often plunges way past -45.
Right, and in parts of Siberia, we're talking conditions that can hit -70. I mean, this isn't just cold. This is the absolute physical limit of life on Earth.
It's the ultimate evolutionary test, really. A test of biology, of chemistry, of just sheer will.
And what's so incredible is that some species don't just survive there. They've actually mastered it.
They've mastered it. They've developed these ingenious, multi-pronged blueprints. Today we're looking at 5 species that have basically hacked the hostile coat of the Arctic. And it's not just about a thick coat. It's about internal engineering and even learned culture.
That's the mission. We've got some incredible material here looking at the tiny but mighty Arctic fox, the quick change artist, ptarmigan, the aggressive wolverine.
The very unique Siberian musk deer, and even the Japanese macaque.
It's millions of years of adaptation, the greatest life hacks for the cold.
It really is.
Yeah.
And what you find is often so counterintuitive to how we as humans think about staying warm.
Okay, let's unpack this. We have to start with the true physiological master, right? The Arctic fox.
Oh, absolutely. It's a marvel of design.
A creature that seems almost built to defy the laws of thermodynamics.
And they are shockingly small.
Mm-hmm.
I mean, you picture this robust animal, but they often weigh just over 3 kilograms. Barely bigger than a chihuahua.
No way. And yet they're living in temperatures that would cause instant tissue damage in almost any other mammal their size.
So the obvious starting point is the coat. It's legendary, multi-layered, and something like 70% of it is this super fine underfur.
Like a natural down jacket.
The best on the market.
Mm.
But the real secret, I think, starts where most animals lose heat first.
Their feet.
Exactly, their feet. Unlike almost any other canid, their paws are completely covered in fur. The pads, too.
The pads themselves?
The pads themselves. Their scientific name, Vulpes lagopus, it literally means hare-footed fox. It's an adaptation you'd expect to see on a rabbit, not a dog.
And it's not just the fur, is it? They're masters of geometry. It's a perfect example of Allen's law.
They are living proof of that principle. Shorter limbs, shorter snout, round ears, a compact tail. It all minimizes the surface area to lose heat. And when it gets really cold, they just curl up into this perfect little ball.
But the truly game-changing hack is the one you can't see. I mean, for us, when our hands get cold, blood rushes there, cools down, and then that cold blood comes back and chills our whole body. How do they stop that?
That is the genius of countercurrent blood circulation. It's a brilliantly simple heat exchange system.
So how does it work?
Okay, think of it like this.
Yeah.
The arteries carrying warm blood from the heart down to the paws run right alongside the veins, bringing cold blood back up. They're touching.
Right.
So the outgoing warm blood heats up the returning cold blood before that cold blood can even reach the fox's core.
So it recycles the heat, the core stays warm, and the paws don't lose as much heat in the first place because the blood arriving there is already a bit cooler.
You've got it. It lets the fox keep its paws just above freezing without risking hypothermia for the rest of its body. It's why their metabolic rate, the energy they burn to stay warm, doesn't even need to increase until the air hits -50 Celsius.
-50?
And get this, they won't even start shivering until it's -70.
That's just, that's unbelievable. And what's amazing is that nature found similar solutions for totally different animals.
I'm thinking of the ptarmigan.
A stunning case of convergent evolution. The ptarmigan is the bird world's answer to the Arctic fox.
They've got the seasonal camouflage, changing from that rusty brown in summer to pure white in winter.
Perfect camouflage. And they also developed what you could call mammal feet.
Right, the mam feet.
They grow this incredibly thick layer of feathers on their feet, and their claws get longer. It's insulation, but it's also like built-in snowshoes. It's why their scientific name is lagopus,
Which means...
hare-footed twice. It's a beautiful echo of the fox.
And those feet aren't just for walking, are they? No, they're essential tools. When a blizzard hits, the ptarmigan uses those claws to dig burrows deep into the snowpack. The snow itself becomes their insulation.
It's fascinating. Both the fox and the bird solve the problem with that perfect orb form and specialized feet.
The physics of Arctic survival are universal.
So let's circle back to the Arctic fox. It's one thing to have the right gear, but you have to eat. That brief summer must be so stressful.
It is a non-stop hunt. They are absolute resource managers. If there are bird eggs around, a single fox might eat over 1,000 of them in a season just to build up fat.
And they have that incredible hunting skill. They use their ears like sonar, don't they?
They do. Their hearing is so precise they can pinpoint the tiny footsteps of a lemming moving under a thick blanket of snow.
And then they do that spectacular vertical dive headfirst into the snowpack.
It's an ambush from above. But their real genius, their foresight, is understanding that the Arctic is the world's biggest freezer. Caching is everything. They bury huge amounts of food, sometimes over 100 birds, and let the permafrost preserve it for the winter.
And when those caches run dry,
That's when things get risky. They become scavengers. They follow the apex predator,
the polar bear.
a very dangerous animal to follow. But the reward is leftover seal fat, a caloric gold mine. And it's why we see them traveling incredible distances, sometimes 800 kilometers across the sea ice, just to stay near a bear.
Incredible. Now, if the fox is a master of storing meat, the Siberian musk deer survives on lichen.
This animal is so specialized, it's closer to an antelope than a true deer, and it survives at -70 on a diet that is almost entirely lichens in the winter.
How is that even possible? There's almost no calories in lichen.
It's a feat of digestive adaptation.
Yeah.
In winter, up to 99% of its diet is lichen that grows on trees, which means they have to become climbers.
Climbers, a deer that climbs.
They'll go up bent tree trunks, sometimes 4 meters high, just to get to their food source.
And they have that other oddity. No antlers.
No antlers. Instead, the males have tusks.
Like a vampire deer.
They're often called that, yeah. The canines can grow up to 10 centimeters long, and they use them for defense. And of course, there's the signature musk gland,
Right, the source of that famous scent.
a golf ball-sized gland they use to mark territory. It's what's made them so valuable to humans and, tragically, a huge target for poachers.
So we've gone from a specialized climber to a creature of just pure aggressive tenacity, the wolverine.
The devil beast.
Its scientific name is gulo, which means glutton.
And it fits.
Yeah.
This animal embodies the high-risk, high-reward strategy. When everyone else is hibernating, the wolverine is awake and on the move. Constantly.
And its fur is basically waterproof, right?
Completely. It's thick and oily, so snow and ice just slide right off. The paws are also huge and furry perfect snowshoes.
But the ferocity is what's legendary. They can take down prey 5 times their own size. How?
It's attitude, but it's also anatomy. They have this incredible bone-crunching bite. Their last upper molar is actually rotated 90 degrees inward.
What does that do?
It acts like a bolt cutter. It lets them tear through frozen meat and crush bone, which is essential when you're scavenging a rock-hard winter kill.
And they can find food when it's buried deep.
Their sense of smell is their superpower. They can detect a carcass under 20 feet of snow. And they don't just find carrion. They actively sniff out hibernating animals and dig them up.
An unparalleled winter predator.
Yeah, absolutely. And once they find or make a kill, they'll spray it with a foul-smelling musk to claim it. It's a clear message. This is mine.
So that's survival through aggression. Let's shift gears completely to our last species, where it's less about ancient biology and more about learned culture, the Japanese macaque.
The snow monkey. This is such a fascinating case. They're the only primate besides us that can survive that far north in temperatures down to -15 Celsius.
And their big adaptation wasn't a biological one, it was a spa day.
Pretty much. The story starts back in the 1960s. A young macaque wandered into a hot spring pool at a local human hotel.
Just by accident.
By accident. And it must have been a revelation. Instant warmth. That habit then spread through the entire troop, socially. They learned it from each other.
A cultural adaptation.
Exactly. It's a learned behavior, passed down through generations. Today, they use their own special pools not just for warmth, but for grooming, for bonding. It's a social ritual now.
So a behavior can be just as vital as countercurrent blood flow.
In their case, absolutely. And they show other clever traits too, like washing their food before they eat it, which is incredibly rare.
We've covered these incredible physiological marvels and this amazing social ingenuity, but all these adaptations took millions of years to perfect.
And that's the tragedy, isn't it? Evolution works slowly, but climate change is happening fast.
So what are the threats?
Well, for the Arctic fox, as the permafrost thaws, the larger red fox is moving north. It's twice the size, and it's out-competing the Arctic fox, pushing it out of its own territory.
And the wolverine?
The wolverine needs deep, stable snow to build its dens and raise its young. That snowpack is becoming more and more unreliable.
And the Siberian musk deer, you mentioned poaching.
It's a double threat for them.
Yeah.
Deforestation is destroying the trees where their lichen grows, and illegal poaching for that musk land continues, which has made them fairly vulnerable.
So all these animals are trying to adapt again, maybe by moving further north to higher elevations.
They're chasing the cold, but the current rate of warming, especially in the polar regions, might be too fast. The very specializations that made them masters of the cold.
Now make them incredibly fragile.
Precisely.
It's such a critical race against time. The key takeaways from this, I think, are just the sheer brilliance of the Arctic blueprint. You have physiological genius, like that heat exchange system, and then you have these incredible behavioral hacks, from creating frozen food caches to, well, adapting a hot spring culture.
We've seen animals that survive -70 degrees by evolving specialized feet, unique organs, and even cultural rituals. And that brings up a final question, something for you to think about. Considering all these brilliant blueprints, what is the most fragile part of their survival strategy? Is it the biology? They can't change fast enough? Or is it the external environment that we are changing too quickly? What adaptation, whether it's physiological or behavioral, do we need to adopt to ensure that these incredible feats of mastery can endure?